Okay, so that's the first example of to find a centroid is using the integral method. So the goal is to find the centroid of this road. So let's say we have a road and we know its shape, we know the function. So we have the function that is x equal y square. Okay, and we want to find the centroid. So you see it's already right in there, but we want to know x bar and y bar. Okay, that's our two unknown. We know that the formula to find x bar and y bar are x bar. It's equal to on the numerator is the integral of x tilde dl. Why dl? Because the road is just a length. Okay, it doesn't have an area or volume or mass. It's just a length, and divided by dl. So we use the same element. For y, it will be the same thing, but with y. Okay, but let's work on x bar first. dl. What is dl? Okay, so dl is a little element, the little gray element. But if we look closer at dl, okay, that's a little element of length like this, and that's the length of dl. And how do we find that? We want to write dl in terms of x and y. Okay, so this is dx, and this is dy. Okay, it's it's a little bit approximative. And if we use the theorem of Pythagoras, the Pythagorean theorem, we can say that dl square is equal to dx square plus dy square. Here we have to pick one of them. We can keep just dx or dy, not both of them. So let's say we want to keep dy. And you will see what I will do. I will divide everything by dy square. So I divide everything by dy square. And what I get is dl square divided by dy square. It's equal to dx divided by dy. Oops, it's an x on the top. So dx divided by dy square plus 1. What is dx divided by dy? We have the function x equal y square. So we have, let's move a little bit, x it's equal to y square. So dx divided by dy, that's the derivation of y, of x with respect to y. So it's equal to 2 times y. So I got dl square divided by dy square. It's equal to 2y square. Don't forget this square there, plus 1. And we see we don't have x anymore. So let's keep going a little bit. Two more steps. So dl square equal dy square plus 1 times dy square. And last steps, dl is equal to the square root of dy 2y square plus 1 times dy. So I take the square root of dy square, it gives me dy. Okay, I was able to write dl just in terms of y. Okay, so I will use this as dl. That's the first steps. Now, in my formula, let me make it smaller so you can see everything. In my formula, I need also to find x tilde. So x tilde, so my little element dl, its center, it's a rectangle, so it's in the middle. Okay, it's in the middle of the L, it's in the middle of dx, in the middle of dy. So it's there. Okay. So that's simply the location of dl on this road at this time. So it's just x and y. Okay, so this is this distance there. That is x tilde. It's also x because it's on the road. And this distance there, it's the y tilde, and it's also equal to y. Okay, So we will need to write that. So x tilde is equal to x, and it's also equal to y square, because remember, we want to keep only y square. And the y tilde is equal to y. And we good, we want y. So we were able to write, let me add one line, and y tilde is equal to y. So we were able to write dl in terms of y, x tilde in terms of y, and y tilde in terms of y. So now we can solve our equation. Okay, so maybe what we can do is we can find the integral of dl first. Okay, let me do this in blue. There. Let's find the integral of dl first. Okay, so integral of dl is equal to the integral of the square root of 2y square plus 1 dy. Okay, what are the limit of L? Because dl now is dy, we need to write the limit of y. So y is going from 0, which color can I take? From 0 to this point. That's the maximum, oops, not this point, this point. That's the maximum y. That's 1. Okay, so the limits are from 0 to 1 because that's related to dy. So basically, you can put this in your calculator. Just your calculator, write with x. Let me see. Okay, so let's see how we will enter this integral in our calculator. I will show you for a TI-84 plus. So that's my calculator. So for integrals, you go on math, and at the number 9, finite integral, number 9. So the limits are from 0 to 1, and the function is the square root of, don't forget any parentheses. So we have 2 times y, and we replace by x, okay? Because in your calculator you need to put x. So 2 times x, close the parentheses, square plus 1. Okay, so we have our 2y, everything square plus 1. And this is in terms of x for us in the calculator. Okay, I know it's y in our example, the way we solve, but for our calculator, it doesn't change anything if you put everything in terms of x or in terms of y in your calculator. And enter. So this is the length of the road. So let's write this on my paper, and let's come back on the example. So we need to solve. Okay, so we found dl. So the integral of dl, and the integral of dl is what? Is L. But let's write the integral of dl. It's equal to 1.479, and it's meter. So that's the length of your road. Okay. Now we need to find x tilde dl, integral of x tilde dl. So for x, let's do x first. X bar. Okay, we are doing x bar. So we want to find the integral of x tilde dl, the numerator, and x tilde is y square. So that's the integral of, and we replace x tilde by y square, and dl, that's this integral dy square plus 1 dy. That's dy, so the limits are the same limits than dl, that the limits for the y, so from 0 to 1. So let's plug that in our calculator. So we come back on our calculator. I hope I didn't close it. Here we go. And again, so math, integral, limit are 0 to 1, that's the limit of y, x square, that's our y square in our paper, and multiply by the square root of, don't forget parentheses, so 2x square plus 1. Do we have everything? I think so. And dx. Enter. So the x tilde time dl, the integral of x times dl are 0.66. And what we need to do, because we want to find after that the division of this one divided by this one. So we take this one. Can we do that for this one? Enter, divided by dl, enter, and that's 0.40998. So that's the location of x bar. Let me come back on this one and let's write everything. Oops. So we find for the integral of x tilde dl, we found 0.606. So x bar, it's equal to 0.606 divided by 1.479, and it's equal to 0.410 meter. So that's x bar. That makes sense because the total x is 1, and it's look like x is a little bit more to the left, so that makes sense. And now y bar. We need to find y bar. So y bar, that was x bar. And let me find, oops. Okay. Let me find y bar. So y bar, the integral is equal to the integral of y tilde dl divided by the integral of dl. So let's find first the integral of y tilde dl. So that the integral of y tilde is y. I need to have to take a little bit more space. Y tilde is y, and dl is the square root of 2y square plus 1 dy, and the limit of y are from 0 to 1. So let's enter that in our calculator. Let me come back on the calculator. Oops. So math number 9, from 0 to 1. And we have x, that is our y, times the square root of the 2 times x, that is a 2 times y square plus 1 and dx. Here we go. Check that you didn't forget anything. Okay, so that's the first, that's the y tilde dl, so 0.848. And to find the location of y, that's this number, divided by the dl, that was 1.47, this one. Oops. Enter. So that it means, oops, I didn't get time to write it, and I think you didn't get time to read it. So that means that your y, the location of the y bar, it's equal to 0.574. So let's write this on our whiteboard. So for this one, we find 0.848, and y bar, it's equal to 0.848 divided by the integral of dl, that is this one, 1.479. So y bar, it's equal to 0.574 meter. Here we go. Let's write x bar equals 0.410 meter. Okay, so remember what we did, just to come back on our steps a little bit. Okay, so first, let's take a color that we don't have. First, we wrote the formula, okay, and because it's dl, okay, we rewrote dl. So that's the step number 2. We rewrote DL in terms of either X or either Y. So we rewrote DL in terms of Y. So we only have Y left inside our formula. And after that, we found DL. We found X tilde DL to find X bar. And after that, we find Y tilde DL to find Y bar. Okay. Sometimes you have to rewrite the function. So here we have X equal Y square. But we could have used the fact that the square root of X is equal to Y if we have used dx instead of dy. Okay, so we can sometimes play with the function. We need to inverse the function, take the inverse of the function. Yes, we didn't use it here, but if we will have used dl in terms of dx, we will have used this formula. And we will have find the exact same answer. There's always two options. You can either write everything in terms of dx or either write everything in terms of dy. Okay, and again, you don't need to do in terms of x for x bar and in terms of y for y bar. Pick x or y and find x bar and y bar with x, both of them, or with y, both of them. Okay, I know this chapter is challenging. So the more we practice, the easier it will get. I see you in the next video. Bye bye.